Troubleshooting BGP adjacencies. BGP is one of those topics that's so big, I decided to break it into multiple nuggets. This first one's going to focus in on the neighbor adjacencies, bringing up the neighbor relationships, because after that's done, you can make sure to focus everything on your routes, making sure you're getting the right routes coming in and going out of your system with BGP. So I'm sitting on router 1. The only thing that's been done is the base IP configuration. Just do a quick show IP interface brief. We can see we've got our serial 00 and serial 01 connecting to two uplink service providers, right? Let's first off, before we bring up the neighbor relationship, save us some troubleshooting time and make sure that we can ping them. 10.1.1.1 and 10.1.1.5 are both responding to ping. Good. Now BGP is the ultimate manual routing protocol. The reason why is because service providers and you, likewise, don't want relationships just forming between public entities where we could influence or they could influence our routing table, right? So BGP has to be a mutually agreed upon protocol on both sides of the game. I'm going to go in into router BGP and then you type in your autonomous system number. Now each router can only be a member of a single autonomous system. Like you can see right here, I'm typing in 500. If I exit out of here and type in router BGP, let's say 501, it's going to be like, nope, sorry, you're already in one, buddy. You can't change that unless you shut down autonomous system 500, right? So once I'm in here, now I can start defining my neighbors. And I do that by typing in neighbor. We give it the IP address of our neighbor. Let's just say 150.1.1.1. And by the way, they have to have a mutual neighbor statement configured on their side, which we'll assume they do. And look at all these commands. Look at that. Just about every command that you do in BGP has the initial word neighbor in front of it, because you apply policies, you apply settings, you apply filters, everything on a per neighbor basis, and that's why there's so many criteria that you can set on a given neighbor. The very first command you always type in for a neighbor is the remote AS. So I'm going to say neighbor 150.1.1.1 remote AS, and we'll put 111. Right? To tell its remote autonomous system. That, by the way, is how BGP determines whether it's going to run eBGP or iBGP, the external or internal version, right? Everything here is going to be external based. So I'll hit the up arrow and do 222 as my remote autonomous system and change the IP address to 150.1.1.5. Now, one thing to get used to with BGP is everything is slow. It's designed from the ground up as a slow routing protocol because it's dealing with a routing table the size of the internet. So we can always verify our BGP relationships through a very unlikely command. I'm going to type in show IP BGP summary, right? This shows the neighbor relationships that are currently in the process of forming. And you can see, look at that. Imagine if OSPF or even RIP took that long to advertise routes or form a neighbor relationship, right? It would be like, man, that's a pathetic routing protocol. And that's what a lot of people think when they first see BGP that way. But remember, when we're dealing with the routing table the size of the internet, you can't have a ninja speed routing protocol. It can't scale and keep its ninja speed status all at the same time. So it's slow by design. So now when I hit the up arrow, I'm able to see that the output has transformed from an IP address with a state of active into an IP address with a state of a number, which represents how many prefixes it has received from that neighbor. That's how many networks it's advertised, right? So now I can type in show IP BGP, And I can see all these routes showing up that have been received from ISP1 and ISP2. Because all those routes have little right angle carets sitting next to them, that means they've made their way into my routing table. So I'm going to do a show IP route, and that routing table should reflect a whole bunch of BGP routes that it's received from the outside neighbors, and it does. Now, I said I was going to focus in this nugget on the neighbor relationship, so let's add a bogus one in there. Router BGP 500. We'll do neighbor. I don't know. I say neighbor and my fingers type network. Neighbor. We'll just do 1.1.1.1. Remote autonomous system. We'll just do 1, 2, 3. Right? Now, when I've done that, I'm going to see it in the IP BGP summary. And you can see right now it's sitting there as idle. If you ever see a word sitting next to a neighbor in BGP, that means something has gone wrong. Idle is essentially saying, I'm not even trying to start that relationship. Why not? Well, you might say. Seems like the other one was sitting there at active, right? This guy's just kind of sitting there at idle. When we saw the other ones before, it was kind of like, well, something seems to be happening. Active means it's actively trying to start that neighbor relationship. Idle means it's not even trying. Well, why is it not trying with this guy, whereas it gave these guys a golden effort? Well, the reason why is because it doesn't know how to reach this guy. If I do a show IP route, you'll notice that I don't have a route to 1.1.1.1. I don't even have a default route. But you know what? Even if I did, here's a key fact for you. I'm starting to get a little ahead into my troubleshooting. But BGP will not use a default route in order to reach a neighbor. So if I'm going to type 111 in there, then I better have a route somewhere in here beyond the default route that tells my router how to reach the 1.1.1 network. Now, BGP may require that you have reachability to your neighbors beyond the default route. But here's an interesting fact. The neighbors do not have to be directly connected. It's a weird paradigm shift because when we think neighbors, that's almost what it means. They're directly connected routers that share routes, right? Well, with BGP, it's almost like an application rather than a routing protocol. It rides on top of another routing protocol typically in order to reach its destinations. For example, you'll see a lot of carriers, like let's just pick Time Warner as a carrier, right? And inside of their, actually they were acquired. They're now level 3. So inside of the level 3 network, you've got hundreds and hundreds and hundreds of routers, right? Tying together all the different POPs and locations that the carrier has. And they have all their connections off to other carriers, right? That's what builds the whole internet. Well, inside of there, the carrier has their own internal routing, right? But the customers never see that at all. It could be running OSPF, ISIS, EIGRP, who knows? Most likely OSPF or ISIS running inside of the level 3 network. But the customer never sees that because BGP can peer from this point all the way over. It's almost like this giant leapfrog hop to the other side of the network. Through all these internal routes, but when the customer does a trace route, what they see is hop, 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 right? They just pass right through the level 3 network, never seeing any of the internal stuff underneath. That's how we can have neighbors that aren't directly connected, but you do have to have a specific route to reach them. So, what other things can go wrong with BGP? Well, we can have the typical interface down. I mean, normal things that can happen with a routing protocol. Layer 3 connectivity is failing. Some IP address failure has occurred. Or wrong source IP. This is a big one. When we set up our neighbors, they have to have the IP address of the partner. So when I go in and say, okay, I'm going to peer from this neighbor A over here on the left to neighbor B on the right, I have to give it an IP address, and because of that, it's usually best to create a loopback interface. I'll just say 1.1.1.1 on A, regardless of what this interface IP or this or whatever interface IPs are, because with the loopback, you can actually advertise it and have it reachable via multiple paths, right? Then I can peer from this IP over to the loopback, or set up a loopback IP address over here on this guy that we advertise into the system and have, again, multiple path reachability. However, if we're going to do that, we have to go into the routing protocol. Let's go back into our router BGP 500. And I can do, let's just do neighbor 2222, and I'll use the command, it's actually right near the bottom, update source. And I would say loopback 0 if that happened to be my loopback interface. I don't actually have a loopback interface yet that I have defined, but that would be what I would type in to allow it to update from that loopback IP address. So when I say wrong source IP address, that's what I'm talking about, is perhaps somebody either forgot to put the update source command, or they have the wrong IP address assigned to the interface that's being used as the update source. You could have an incorrect neighbor statement, meaning I type in neighbor 2222 when it really should be 2223, or I type in the remote autonomous system incorrectly. You could have an ACL between the two. BGP, unlike OSPF or EIGRP, runs at the application layer using TCP port 179. So if you have a firewall blocking that, your BGP relationship won't form. Authentication with BGP can be done using MD5, right? It's very easy to do. All you got to do is modify your neighbor statement. So on both sides of the connections, you can type in neighbor such and such password, and then you type in whatever shared secret you want to have between the two, ASDF, ASDF. And what happens is, as long as you type that same password in on both sides, it will now send an MD5 hash representing that back and forth with every single packet that's sent dealing with BGP, so you can authenticate it came from the right source, right? So some of the commands I've actually already typed in. You can see I've got the big one, show run section BGP. And that will show you the router BGP and all the commands that are underneath it, which is very handy to verify. Show IP BGP summary is the one that shows the neighbors and their current status. Now, that is being replaced by a new command, show BGP IPv4 unicast summary. As we move more and more into the IPv6 world, I'm seeing a lot more of that, where instead of just saying IP, things are being changed and represented now in IPv4. The one that everybody types, I used to all the time, to first think of viewing the neighbors, show IP BGP neighbors, is not the command you want. This one, if you take a look, it says, okay, you got neighbor 1, right? He's got oh, there's neighbor 2. I mean, it's just too much information about every single neighbor. Yeah, if you're really into the nitty-gritty, let's see what's going on with those neighbors, you can go here, but it's just information overload. That's why that show IP BGP summary command is so handy. Last thing I want to mention, I didn't put up here, but I think it's worth talking about, is debugging. If you ever find yourself stuck, let's just do a show IP BGP summary. Like you're looking at a neighbor relationship where you're going, okay, what's the deal? Yeah, now, obviously, I've just told you idle means it's not even trying. Check your routing table. Make sure it knows how to get to 1111. Active. What if it's cycling between active and idle? It's disappearing from this table. It's popping back in. Well, that's where you might want to do a debug, IP BGP, and I usually just type in all. Like, give it all to me. Because usually there's not too much chatter with BGP. Then I can do a clear IP BGP, and we'll do a star. Clears the neighbor relationship. This will actually show you, now I'm watching two neighbors form right here. This will actually show you every single step along the way of the neighbor forming process. So you'll be able to see, okay, we went from idle to active, meaning I'm trying to form that neighbor. It shows the local address. We're trying to communicate with the other side. We've sent our open message. Hey, we're starting to exchange. We have route refresh capability. I mean, again, open send, open confirm. You can see every single thing along the way to where if the neighbor doesn't form, this command can actually show you right where it stops. That can be really handy if you're troubleshooting those neighbor adjacencies. Well, that is your initial view of BGP troubleshooting. I hope this has been informative for you, and I'd like to thank you for viewing.